In this video, we're going to start looking at the language and rules of logic. And as we talked about in the last video, our goal is to start analyzing arguments. But to do that, we need some language and some structure in place. So first, a proposition, which we talked about last time, makes a claim that may be either true or false. So it has to have a true or false nature, and it needs to be the structure of a complete sentence. So let's look at some examples so we can kind of determine which would be a proposition. So over the mountain and through the woods, that has no true or false nature to it. So this would not be a proposition. All apples are fruit. Okay, that has a true or false nature. It is a complete sentence, so this would be a proposition. The quick brown fox. It's kind of an incomplete sentence, right? It needs more information. And of course, it lacks true or false, so this would also not work. Are you here? A question would not work at all. 2 plus 3 equals 23. This is a mathematical sentence. And if you were to write it out in words, we would write that the sum of 2 and 3 is 23. And that is a sentence. And it has a true or false element. In this case, of course, it's false, but that then would qualify as a proposition. Okay, so the opposite of a proposition is called a negation. So we will use P to represent our proposition. The statement, it is not the case that P is also a proposition because we are making a true or false claim. And we call that the negation of P, which we put this little squiggly in front of the P. And when we see that in math, that reads not P. That squiggly is called a tilde. So we put that little tilde in front of P to mean not that, the opposite of that proposition. Okay, let's look at an example. If the proposition is the sky is blue, the opposite would be that the sky is not blue. Or you could say the sky is something other than blue. Now, what we're going to be looking at are called truth tables. Truth tables are ways to kind of look at where arguments are flawed versus valid. So when we have an R statement, R being our proposition here, and we have two facts about R, we're either saying R is true or false. That means that when we throw the tilde in front and we're talking about the opposite of R or not R, then it has the opposite of true and falseness. Not R would be false, whereas if the first R is false, then it would be true. So it has opposite in terms of its truth. That's a truth table. And we're going to look more at that in the homework. So in the definition above, we use a truth table. A truth table has a row. Oh, that's highlighter. Let me switch back to my pen. Has a row for each possible set of truth values for the propositions being considered. Any proposition has two possible truth values. It could be either true or false. If a proposition is true, its negation must be false, and vice versa. That's how the truth table would work. Okay, let's look at an example. Let's do some negations of these propositions. Nobody likes ice cream. So the negation of that could be everybody likes ice cream. And there are different ways of wording this that could be equivalent. So there's nothing wrong with wording it slightly different than how I have it worded. All politicians are liars. So the negation of that would be no politicians are liars. Oops, I missed the I. No politicians are liars. Okay, some of my friends are taking risks. So when there's a some case, you can do a some opposite. So in other words, you could say some of my friends are not taking risks. That does become difficult because that's not really a negation, right? Since if you're saying that some of your friends are afraid of taking risks, to say some of my friends are not taking risks is not really a negation of that statement. It's kind of the opposite truth, the other part of the statement. So to actually negate it, you would have to contradict the statement that's there. So I'm going to redo this one. If it'll let me erase. There we go. And instead, what you want to say is that none of my friends are afraid of taking risks. That's a negation. Or you could have said all of my friends are afraid of taking risks instead of just some. But in order to actually negate it, we have to give an opposite, a true or falseness to it. Okay, nobody's perfect. Everybody's perfect. Okay, so what we have, or I should say what we're moving into, is different ways of combining propositions. So what we just saw is the opposite, how you do a negation of a proposition. So now we're going to talk about if we put two propositions together. If you say P and Q, which in math, we're going to use this upside down V to represent and. This is called a conjunction. Oops, wow, that's not how you spell conjunction. Conjunction. And it is true only if P, oh, sorry, there's a missing, and Q are both true. In other words, if you say that you put two propositions together with the word and, the only way that statement is going to be true is if both of those propositions are true. Okay. So the idea is if I were to draw a truth table of this, and I know that both P and Q are true statements, that means that when I combine them together with and, that is a true statement as well. But if Q happens to be false, the whole proposition, the combining of the two, the conjunction will be false. Same with if P is false, or of course, if both are false. So that's how you would draw a truth table to express what happens in this specific conjunction. There's only one case where we have truth in the statement, and that's if both the propositions happen to be true. So for or is a little bit different. If you're given two propositions, there are two types of or, by the way. There's two ways you say or. There's the inclusive or, which means that either or both. It could be referring to one or the other or both together. Exclusive means it has to be one or the other. Only. Can't be both. In other words, one or the other has to be true. Okay, let me give you an example of this. I have been kind of avoiding that. So let me come up here for the and. An example, if P happens to be cats are, oops, that's not high school cats. Cats are mammals. Okay. And Q happens to be, oh, let's see, dogs are reptiles. Those are my two statements. Now we happen to know that the second statement is false. So if I were to use a conjunction, if I were to say P and Q, oops, looks like it's one word, P and Q. And I make the statement, cats are mammals and dogs are reptiles. That statement's false simply because the last half of the statement is false. So this would be an example of this argument where P happens to be true, but Q happens to be false. So the whole statement is false when I put them together. That's how you would kind of use the truth table. But using that same P and Q for or, okay, for when we're talking about or, you could say P or Q, cats are mammals or dogs are reptiles. So what that allows for is that one of them could be true. That's in the exclusive or. The other is the inclusive or, which could be that either of them could be true or they both could be true. In this case, this would be an example of an inclusive or, where I'm making a statement where they both could possibly be true at the same time. However, an exclusive or would be eliminating that. In other words, if P happens to be cats are mammals and Q happens to be cats are not mammals, the negation. In this case, that would be an exclusive or. Only one of them can be true. They both can't be true because they contradict each other. So that's the difference between an inclusive or and an exclusive or and the argument of and, the conjunction. All right. So let's look at the or truth table. Since if both of them are true, that's a true argument when we combine them together with an or. If one of them is true, because we can assume that it might be one or the other, in either case, that is a true argument. In both the inclusive and exclusive case, it could be the case that only one of them are true. So this would work too. That means that we have a true sentence. So it's only the case where both statements are false is our proposition false. Okay. So when I say cats are mammals or, oops, cats are not mammals, that's a true sentence. Like I've made a true statement because I've allowed for the option that has truth. Even if I use this one, cats are mammals or dogs are reptiles, that's a true proposition as well, because I've allowed for one of them to be true. But the minute they're both false, that's where we have a problem. Okay, so let's look at some examples of this. George Bush or Elvis Presley was a US president. So that could be true because we happen to know George Bush was a US president. 1 + 1 = 2 and 2 + 3 = 4. So for and, they both have to be true. And since the second part of it is false, this would be false. Cats and lizards are mammals. That would be false because lizards are not mammals and it's using an and. Oregon is a US state or Idaho is a US state. Well, that would be true. And happens to be the inclusive or because they're both true. All right. Conditional statements are called conditional because they propose something to be true. And then also known as conclusion on the condition that something else is true. This is the if is called the hypothesis and the then is called the conclusion. So for example, if you play well in practice, then you will start in tomorrow's game. So the idea that if the first part happens, then the second part will happen. The second part follows if the first part follows. So this structure says then that if the first part comes true, the second part needs to come true in order for this statement to work. So let's look at what happens if we look at the different possibilities. You play well in practice, you start in the game. This is the outcome that we would best like to see happen. If you play well in practice but do not start in the game, this means that your coach lied to you. You didn't play well in practice, but you start in the game. Well, because the if-then statement doesn't talk about what happens if you don't play well in practice, it just means that you may or may not start in the game. So this is an okay statement, that your coach was merciful to you. Your coach allowed that you could start in the game, even though you didn't play well in practice. You don't play well in practice, you don't start the game. Well, most people feel very comfortable with this because we feel like that's the opposite of what the if-then statement is. But the only one that's really problematic is B, because B is a direct lie of what the coach said was going to happen. Everything else really is not in any way a contradiction to what the coach said was going to happen. Even part C, because not playing well in the game, the coach didn't talk about that. The coach didn't say, if you don't play well in the game, you're not going to start tomorrow's game. I'm sorry, if you don't play well in practice, you're not going to start tomorrow's game. So the idea is it's really only part B that is a bad statement. Now, I want to kind of build on a truth table for this then. So if the first statement is true and the second statement is true, then your coach did not lie to you. If your first statement is true, but the second one is false, your coach lied to you. So the conclusion did not follow from the if statement. If the first statement happens to be false, but the second one true, that's okay. Your coach didn't lie to you. They just didn't talk about what would happen in that case. And that's true for the last case too. If you false, the coach still didn't lie to you. So this is how we build the truth table for an if-then statement. So a conditional statement is only false when the hypothesis is true, but the conclusion comes out false. So there's only one case where this argument fails, when the first part happens to come true, but the second part does not come true. Let's look at some true or falses. If cows can fly, then pigs can fly. Sure, that works, because they're both false. If a cow can fly, then a pig can fly. Sure, but neither is happening. Therefore, there's nothing wrong with this statement. If cows can fly, then sparrows can fly. Well, that works also, because sparrows can fly no matter what. It doesn't matter if the cows can fly. But sure, if the cows can fly, then sparrows can fly too. In this weird world that you're creating about cows flying, that could happen. If horses are mammals, then lizards are mammals. That's false. And the other part does not follow. So because we're saying that horses are mammals, and they are, then lizards are mammals, they aren't. That's a false statement. But if I tell you that if cows can fly, then sparrows can fly, sure, in whatever weird world you live in where cows fly, okay, sure, sparrows can fly. Because in your world, if these cows are flying, sparrows are flying too, because sparrows fly anyways, regardless of whether or not cows are flying. If a person is running, then he or she is breathing. That would be true. Because that is a true statement. Somebody's running, they have to be breathing in order to run. They won't run very far. All right. So let's look at some combo propositions, then statement, even though it doesn't say if then. So we're going to make them into if then. So he's over 35 if he's president of the United States. So that's telling us that every president has to be over the age of 35, right? So if we're going to put this into an if-then statement, I'm going to abbreviate it US, then he is over 35. So that is a condition of being the president. Every square is a rectangle. So in this case, we have an every statement. So every square happens to also be a rectangle, but the reverse is not true, right? Every rectangle is not a square. So if it's a square, then it is a rectangle. So it being a square automatically qualifies it to be a rectangle. Babies cry whenever they are hungry. So if a baby is hungry, wow, the A is in the wrong spot. If a baby is hungry, then they will cry. So there we go. That's how you write that as an if then. No turkeys like Thanksgiving. So if it is a turkey, then it doesn't like Thanksgiving. Sorry, my dog is barking in the background. Oops, let me go ahead and give myself more space. Then it doesn't like Thanksgiving. And there you go.